Yes, sir.
For equation for maximum height reached by a projectile. This is the heading you have given. So now for this we draw a diagram. This is Earth, center is here, radius is here. We are having a body at a point A on the surface of the Earth. This body, we are projecting it. This is R. We are, this is the maximum height, B. This height above the surface of the Earth is H. From here, from the surface of the Earth, we are projecting the body. How high will it go? Maximum height, we will find that. Okay. We will not use that formula, this one, V square is equal to U square plus 2GH1. That formula we will not use. Let us see the formula now, how the formula changes now. We know that the energy at all points are equal. We write energy at A equal to energy at B. Write down here. That energy at A equal to energy at B. We will write this first. What energy will it have at the point A? It will have potential, gravitational potential energy and also the kinetic energy because we are throwing with some velocity here. So it will have potential energy. The formula potential energy will go like this: minus Gmm by R. The distance from the center of the Earth to the point, this is R, plus half mv square. Small mv. Small mv is the mass of the body which is being thrown. Capital M is the mass of the Earth. R is the radius of the Earth. And at the point B, what energy will it have? It will have only the potential energy at this point. Because maximum height time, the final velocity becomes zero, then kinetic energy will be zero. Here I will be writing that is minus G M, but the distance of this point from the center of the Earth will become R plus H. Here I write R plus H. R plus H. This much. No kinetic energy at the point B. Okay. What I will do, I'll bring this one that side and I'll be making H the subject of formula. Somehow to make the H subject of formula. M, we can cancel. You can add half V square equal to, this will go that side, become positive Gm by R minus Gm by R plus H. From here, no, we have to somehow make H the subject of formula. I'll continue for the right, half V square. Take LCM of this. LCM is coming R bracket R plus H. And Gm is common. I can take Gm as common here. Gm is common. Gm is common. Gm is common, and within bracket we are solving it. Gm is common. This will come R plus H minus R. R and R cancel. We get half V square is equal to Gm value. I'll put GR square, and here I'll let H by R plus H. You can make a note here, since small g is equal to Gm by R square. Therefore, Gm value will become GR square. G small g R square. Here I'll cancel this and this will go. I'll do cross multiply. It will become V square into this V square R. This into this will become V square H is equal to this side. We are getting 2GRH. 2GRH. We'll get this. Then keep H on one side, right? V square R is equal to 2GRH minus V square H. V square R equal to, taking H common. H common, here it will become 2GR minus V square. Therefore, H is the subject of formula. Therefore, H value will come V square R by this value, 2GR minus V square. So this is the formula. This is the formula of maximum height reached by a projectile. Please complete. If any step you have not understood, clarification, I'll clarify. check and let me know if any step is not clear to you.
So that V step,
Which one?
so the third last line,
Which step?
the third last.
This one. Here.
Yes,
This
sir.
one. Cross multiply.
Yes, sir.
V square is V square R. V square into H is V square H. Cross multiply 2GRH. 2GRH. That is the simplest step. Simple. Now, which other step? Please ask me. Or if it's all clear, tell me that also. Is it all clear?
Sir,
Okay.
yes, sir.
Okay. Now, give the heading. Next heading we give. Next heading we give. Expression for escape velocity. Expression. Give the heading. Expression for escape velocity. Escape. ESCAPE velocity. Expression for escape velocity. Expression for escape velocity. Okay. Let me escape velocity. After that, I'll find expression. What is the meaning of escape velocity? Escape velocity is the velocity given to a body so that the body goes beyond the Earth's gravitational pull, beyond the Earth's gravity, and it doesn't return back, doesn't come back. Such a velocity is called escape velocity. The velocity of a projectile from the surface of, just now I'm talking about escape velocity for the surface of the Earth. It will differ from different surfaces. It may differ for Moon, escape velocity for Moon surface, escape velocity for Mars surface. It will vary. Is the velocity given to a projectile so that the body does not return back to the surface. If it is Earth's surface, it will go beyond Earth's gravitational pull. Such a velocity is called escape velocity. Escape. The body is escaping the Earth's gravity. It will never return back now. Whatever thing is there within the gravitational pull or within the gravitational field of Earth will return back. But if the body velocity is too high, then what happens? The body will not return back. The body will go beyond Earth's gravitational pull. Now we are going to find a formula for it. What formula? And we'll check the calculation also. Like what is the escape velocity of a body on the surface of the Earth? Okay, let us check. So to find out this formula, the same diagram is same like this. Here is radius is r, mass of the Earth is m. Here is the body, and the body is going to a point B, infinity. Infinity means we don't know where the body is going. The body is escaping our surface. The body is going to an unknown place. We do not know. So for that also we'll be writing energy value. Write energy at A equal to energy at B. Energy at B. Energy at A will be what energy? Minus Gmm by R plus half mv square. And energy at B will be 0. Because the body is going beyond Earth's gravity, the energy is suddenly becoming 0. That's why the body doesn't return back. So this thing I'll say on the other side, it will become that is half mv square is equal to Gmm by R. Cancel M and M cancel. You get half V square is equal to Gm value is put Gr square. Gr square by R. R cancelled. Therefore V square value is becoming 2Gr or V value is becoming root of 2Gr. This V is what velocity? Escape velocity. Escape velocity. That we will write like this. VE is equal to root 2GR. That we will write like this. V with the subscript E. V is equal to root 2GR. We can do the calculation also. We can find the value of VE. Write down VE equal to root 2 G value on the surface of the earth is how much? 9.8. Radius of the earth is 6400 kilometers. 6400 into 1000 we will do 1000. And now we will calculate this answer. I am sure when you use calculator and find the answer, your answer will come 11200 meter per second, which we will change into kilometer. How do we change into kilometer? Divided by 1000. When you divide it by 1000, the answer will become 11.2 kilometers per second. Timing we are keeping same, but meter only we are changing in kilometers. 11.2 kilometers per second. This is the value of escape velocity for the Earth surface, for the surface of the Earth. That means if a body is given this much velocity, the body is sure not to return back. Not to return back. So this is called escape velocity. Have you understood? The body will go beyond Earth's gravity. The body is not going to return back. Just imagine the velocity value is too high. In 1 second, it should go 11.2 kilometers. 11.2 kilometers. Maybe from this school, the 11.2 kilometer may be distance from here to Chitre, maybe. In 1 second, the body must cover that distance, that much distance. You can just imagine. Then the body is not going to return back. You have to give the velocity like this, the body will go beyond Earth's gravity and will not return back. But this is the formula of escape velocity for the Earth surface we are finding. But if it is Mars surface of the Mars, we have to take G on the surface of the Mars, whatever is the value of G we have, and R value will be the radius of that particular surface, radius of the Mars. If it is about Moon, so Moon value will be same as G on the surface of the Moon, and R will be radius of the Moon. Radius of the Moon as compared to the radius of the Earth is much less. It is 1 by 81 times. And the value of G is nearly 1 by 6 times. So using all these values, when you calculate the value of escape velocity on the surface of the Moon, the value comes very low. The value comes very low. That's why the atmosphere, there is no atmosphere in the Moon because the escape velocity of the surface of the Moon is having very low value. The atmosphere is escaping from the Moon surface. Escaping. Because the radius of the Moon is less and the value of G is also less. So this is the formula for escape velocity, root 2GR, square root 2GR. And the numerical value we calculated and it comes 11.2 kilometers per second. Finished? Yes? Done?
Sir.
Tell me.
Yes, sir.
Anything you want to clarify, please let me know. It's okay?
Clear.
Clear, okay, thank you. Now we will be doing the motion of satellites. Write down motion of satellites. Motion of satellites. Motion of satellites. Motion of satellites. Okay. Motion of satellites. Motion of satellites. This may be the surface of the planet. Maybe I'm considering Earth, mainly Earth. And here are the satellites revolving around. Satellites are revolving around. Here is a satellite. Here is a satellite. Satellite mass I take M, mass of the Earth is capital M. The total distance is, this is actually R, this one is H. Therefore, small r value will be r plus h. Total distance will be from the center of the Earth will be r plus the height of the satellite. So for a satellite revolving around a planet, what provides the centripetal force? Because the satellites are revolving around a planet. So there is a centripetal force required. What provides the necessary centripetal force? This can we say force of gravitation. Force of gravitation, yes. You can write it also as force of gravitation. Force of gravitation equal to centripetal force. Mention that. Centripetal force. Centripetal force. Force of gravitation is equal to centripetal force. Force of gravitation formula we have G M M by R square, small r square. Centripetal force formula letter mv square by r. M and n cancel, small r cancel. You get v square value is coming G M by r. Therefore, the value of v will come root of G M divided by r. This v is called orbital velocity. Orbital velocity. This v is called orbital velocity. The velocity of the satellite in the orbit, the velocity. It is not the velocity scalar velocity you give it here, okay? But this is the velocity with which the satellite is revolving around. That is known as in the orbit. That is why it is called orbital velocity. And we can denote it by VO. VO means orbital. VO means orbital velocity. You should learn the technique, okay? Technique is gravitation is equal to centripetal force. This is equal to this, and we have the answer coming. Okay, now we just write here for a satellite very close to Earth's surface, for a satellite very close to Earth's surface, we write VO equal to GM by, if the satellite is very close, that means this H is negligible as compared to R, radius of the Earth. I am just giving one example. Suppose that satellite height is only 200 kilometers, 200 or 200 meters, for example, 200 meters, only 200 meters. With respect to 6,400 kilometers, if you change into meters, 6,400 into 1,000. That means 64 lakhs meters. 200 is nothing, no? With respect to some lakhs, only some hundreds are almost negligible. For a satellite very close to the Earth's surface, this small r and capital H is zero in comparison to H, negligible. That is, small r value can be replaced by capital R. Here I write capital R. Now we'll continue a little further. GM value are at GR square, right? On GR square divided by R. R cancelled. Therefore, VO value will become root of GR. Escape velocity formula is root 2 GR, but orbital velocity for a satellite close to the Earth's surface, very close to the Earth's surface, the formula becomes VO equal to root GR. If the satellite is not very close, then we have this formula. V naught is equal to root GM by R. And if there is a need, we can express GM is equal to GR square. This one we can have GR square divided by small r only will remain, because nothing will cancel now in that case. But when the satellite is very close to the Earth's surface, small r and capital R equal, so the answer will become root GR. So this formula is only applicable for a close satellite which is very close to the surface of the Earth. So if you put the value and all, G value if you put 9.8 and the value of R is 6,400 kilometers, 6,400 into 1000, your answer will come now. Calculating this Please check the answer. Please check your answer. How much is answer coming? I don't remember exactly. What is answer coming here? Tell me. Square root of whole thing put under bracket and do the calculation in calculator and tell me the answer coming. 7.92. Please check. Check it. I don't remember the exact value, but I know the technique. What is the answer? Hello, one of you please tell me the answer. Yes.
7919.
No one can calculate.
7919.
7919. That means in kilometers, the answer will come 7.92 kilometers per second. 7.92 after rounding off. In kilometer, you are changing. This answer is coming in meter per second. You are dividing by 1000. This answer I am changing it to kilometer per second. The answer will come 7.92 kilometer per second. Okay? Done?
Yes, sir.
Okay. So this is the formula of orbital velocity, root gr. We write one more equation. We can write down v escape equal to v escape equal to root 2 times of v naught. This relation holds true. V escape is equal to root 2 times of orbital velocity. But this orbital velocity only for a nearby satellite, the satellite which is close to the surface of the Earth. This one is applicable for only that. Root 2 times if you multiply here, then you get escape velocity. But the meaning is different. The nearly escape velocity is equal to root 2 times of orbital velocity. This is the relationship between them. Done? Finished?
Yes, sir.
Yes. Okay. And I'll tell you one more thing. How to calculate the period of revolution of such satellite. The satellite which is close to the Earth's surface. How to find the period of revolution? How much time it will take to complete one revolution? How to calculate that? To calculate that, we continue from here. We can write that v naught is equal to for nearby satellite root gr. Squaring both the sides, v square is equal to it becomes gr. V is equal to omega r and like omega square r. R square is equal to g r will go. Omega square value will come g divided by r, and omega value will come root of g by r. Root of g by r 2 pi by t will be equal to root of g by r. Therefore, time period value will come 2 pi square root of r divided by g. And the value of r, you know, this is the radius of the Earth, and g is the acceleration due to gravity on Earth. If you divide and calculate, your answer will come. First, your answer will come in seconds. If you divide by 60, it will change to minutes. Network problem, huh? Yes. So such a satellite will take how much time to complete one revolution around the Earth? This much, 84.6 minutes time, which is nearly 1.41 hours. 1.41 hours. 1.41 hours. Okay? Done?
Yes, sir.
So now only little bit is left in theory. Next class I will talk about geostationary satellite. Okay, and we'll start the problems in the next class that we are having today only. No, the next class, that time I'll discuss. Okay, thank you.
Sure.